Hello students, welcome back to OrganiChemVerse. Today I have taken a question from aldehydes, ketones and carboxylic acids chapter. Let's understand the concepts better by solving this question. First, identify the functional groups present in the reactant molecule. You see this is a cyclic ester, nothing but a lactone. If the lactone is 5-membered ring, we call this as gamma lactone. You can also see here the oxygen is attached to carbon and carbon. So it is a cyclic ether. And whenever the carbon is attached to oxygens and a carbon and hydrogen, you can call this as an acetal. So these are the functional groups present in the molecule. And when it is treated with aqueous sodium hydroxide followed by heating in presence of an acid, what should be the major product? Among all the functional groups, you know that ester is more reactive. That means what? When the bicyclic molecule is treated with aqueous sodium hydroxide, the first reaction is hydrolysis. But where the hydrolysis will happen, it will happen at the ester. So this is a reactive center. Ethers will undergo hydrolysis in acidic medium, but what is given here, it's a basic medium. So ester will undergo hydrolysis first. So you can see that the OH will attack here, the ring will open. So you see the 5-membered ring opening means here we are going to get a chain of carbon. So how to write the product? Very simple. You just follow this. See, this ring is not changed. You write that as it is. So when this bond breaks, right, the oxygen will take away the electron. So you write that as well. What about here? You start writing the carbon here, this one, CH2. And then what happens here? You're going to get COOH. So this is an open chain we got upon hydrolysis. Now look at this molecule. This carbon is attached to two electronegative elements, that is oxygen. So oxygen having negative charge itself is not stable. So what will happen now? It will give its electron to this carbon. See, this carbon is already having 4 bonds. When the electron moves here, this carbon cannot withstand 5 bonds. What it does? It will break the ring. How it will break? Look at this like this. But why it is breaking here? Because oxygen is an electronegative element. So it will withdraw electron from here. It's helping to take away the electrons from this bond to the atom. So how I have written the arrows, based on that only you have to write the structure of the product. So how do you do that? I'll give you a simple trick. Start numbering from here, this carbon 1, 2, 3, 4, 5 and the oxygen is 6th atom. So this is the longest chain of carbons you can see, right? And when the bond is breaking here, this is gone. So now based on this, let's write down the structure of the product. So you write down COOH, right? This is first carbon, second, third, fourth, fifth, and sixth is O minus. So if you want, you can just write down the numbers as well so that there won't be any confusion. So now this is the O minus. Then where is this aldehyde group? When the electron goes here, COH. COH means what? This is nothing but an aldehyde. So that is a formyl group present on the third carbon. Now, is this the product from the options? No, not possible, because you see all of them are cyclic products. So somewhere this molecule is again undergoing cyclization. So which two groups will undergo cyclization? Look at this. When this oxygen attacks over here, we are going to get a 6-membered ring. If this oxygen attacks here, right, it's nothing but we will get back the same reactant. So don't do that. So it will attack the acid. So this is oxide attacking acid, means we are going to get the ester. How many membered ring? So you know that the oxygen is 6th, right? So 1 and 6 means it's going to be a 6-membered ring. So you write down that first. So this is the 6-membered ester molecule we got, nothing but lactone. What else is missing? At the third position, we have a formyl. So how do you number it? Always number the carbon chain. So 6th is the oxygen atom. So at the third position, we have an aldehyde like this. Now let's check what are the options given here. See, this is an ester. This is anhydride. Eliminate this. This is an ester, but there is no aldehyde. Therefore, you can eliminate this also. This is an ester and aldehyde. So that means what? The positions of the formyl groups are different. So let's verify that. So if we number from here, at third position, formyl is there. Therefore, that itself is the correct answer. What about here? It is at the second position. So not possible. So generally, students, when there are 4 options, 2 options you can eliminate easily. So you just compare for the other two options and get the right answer. I hope I made this concept clear to you. And if you still have any questions on this or any other question, please ask your queries in the comment section. And don't forget to subscribe the channel. Thank you.